Good evening and welcome back to Astro Colony, where I am heading over to our science because I have been making some motherboards and some aluminium bars. Oof. And I've been making them because we need them in order to do some of the research we want to do. We have 2, 5, 9 space science in order to get through here, and we have everything we need for that, because that's what I want to get. I want to get signals. I want to get signals so we can have an inventory sensor and a decider. I'd also like to get arithmetic. I think we can do that one as well. We have plenty of the chemistry science, so we're gonna beeline down to there and get arithmetic so that we can start working on things. Start working on our setup, as it would be. If I come back over here, I have filled in the roof. This has all been filled in, it's solid now. Does not have any ore in it, so these pipes are connected to the pipes at the top. Almost, there's one block in between them because I haven't put them down here because I don't know exactly what I want to do with it yet. But we're going to bring them down here, and then we're going to have the stuff either go directly into a storage, which I kind of think I might do. We might just plug it straight into a storage, and then from there, from the storage, we'll come out and we'll filter things and do other bits and pieces. So kind of the idea, but I need to understand how the logic blocks in this game work. I have to figure them all out to get everything doing what I want it to do. So we're going to have a little bit of a play with that. Now I kind of get how the pipes are doing their thing. I think it's about time we worked on some automation. Goodbye. Awesome. Okay, one bit of research done. Navigation is the next one. We can't do navigation because we need advanced engines. Okay, so we probably need more than what I currently have done, which is a little bit annoying, but okay, we'll do advanced engines, then we'll do navigations, then we'll do electronics, then we'll do signal, then we'll do arithmetic, and there will be much rejoicing. And with the research finally done, we can do electronics, we can do signal, and we can do arithmetic. Oof, awesome. Now we have all the things we need to create the automation. All we need to do is figure out how it works. So let's go back into here where we have nothing. I have put a storage in, I haven't connected it to anything yet. I've been looking at kind of the layout I want to do it because I want multiple outputs. So we have switched this storage around to have the person output swap around, so it's got one input on each side and multiple outputs. So I think that's going to work better for us, I think. Okay, so let's have a look at these logic blocks and see how they work, shall we? Let's throw some logic down onto this bar. We'll go number 3, and we'll just throw all the logic down here. Bump, 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 and we have cable as well. Bump, and then there are signal receivers and senders, so you can send logic long distances. I think, I don't know how this works. We'll figure it out. Okay, a decider, an arithmetic, an inventory. So the sort of thing I want to set up is, if we have less than so many iron bars in storage, we want to smelt some iron. Now the drawback to that is that we would need to be storing all our goods in, but we want to store them in the warehouses, because the warehouses we get access to build things. But we don't need to necessarily store ore in a warehouse because we don't need access to ore. But we can store ore in standard warehouses. But the problem is that if you have a system set up going, I would like, well, you have a puller, and you go, okay, so this is going to be iron. This pulls iron. And then you have a system set up that turns this on or off depending on, I mean, I don't even know if you can turn this on or off with logic. Let's try this. Let's Let's build a thing. Let's build a thing. Build a testy thing. Device. Give me another warehouse. That'll do. Oh, warehouse. Oh. And then go to F2. Build me a smeltery. Get rid of that. Build me a smeltery. Oh, smeltery. We'll just put it there for a minute. Okay. Okay. And then we'll put a connection in between it. Off like that. Okay. And then we have a storage back here. I'm going to go with storage container just for the moment because it's going to be easy to do. It will work with the big containers as well, but we'll go with storage container. Right. So what we want to do is we want to have a puller here. Okay. And this pusher, sorry, which is a pusher here, wants to be filtered to iron, but it only wants to activate if this storage has less than, we'll say, 10 iron bars in it. So let's figure this out, shall we? Let's figure this out. We have inventory, arithmetic, decider. Okay, so I need to do an inventory sensor. They have to be connected. Oh, okay. Oh, no, that might not be too bad. That might not be bad. We might better run it higher and put them above because this is a multi-block thing. So yeah, because all the inputs are on the ground level, we might better run it. But let's say we might. Let's not do we might. Let's not do we might. Let's do we will. Let's put them up by 2. We put a floor in, like so. Floor in, so. Remove those, and then we'll do an inventory sensor here. Does that connect? It does connect. Awesome. Okay. Boom. And this wants to check. Pick device. Oh, you can pick. Okay. Okay, so they can pick. Okay, so you even if you put them in facing the wrong direction, it's fine. Okay. This wants to do iron ore. Boom. So this is detecting, no, not iron ore, iron bars. This is detecting iron bars. Okay. And all it does is just go, yes, I've got iron bars. Okay. Then I would guess we're going to go with an arithmetic center like this, and we need cable, which conveniently we have lots of cable anyway, so this is a big problem. Like that. Does that connect up? And this wants to go if iron bar is that's the less than symbol, but it's a double less than symbol. Hold on, this is arithmetic. That's not what I want. I want decider. I don't want to. I want decider. Sorry, decider. Ah, there it is. So if iron bar is less than 10, okay, then controlled device is off. Right. So what's the control device? The control device is going to be up there. Do we have to run? We can figure out the cable and tidy up stuff from there. Boom, there you go. Think. Do that. Okay, anything you can see. Okay. So we don't have to connect this by cable. No. Okay. Okay, that's good. That's good. That's very good. That's very, very good. Okay. No resource. Fine. If iron is less than 10, then turn this off. So it has turned this off. So if you want to go, if iron is greater than 10, okay, then we turn this device off. Okay. Greater than greater than or equals to 10. Okay. Then we turn off this. Is that right? Do we have to run it? On. Big device. That one. Okay, I'm confused as to why this is. If it's greater than or equal to 10, then we turn it off. You shouldn't be turning it off. We are not greater than or equal to 10. We are at 0. If I put those in there, Generate signal is 10. Put them back in again. Hold on. Oh. 6,000. Okay, so you've generated a signal to say the signal's coming down and into this, and this is greater than 10, so that should be turning that off. That's correct. Okay. So if I then take this out and then I go and put a single one in there, this should be reading 1. Yep. This should be reading. It's not greater than 10. So why is it off? Confused. Do we need a cable? Do we need a cable? Is that how this works? We do. This is not working the way I thought it was going to work. In fact, I am blatantly confused by this because you're reading 1 and you are sending the signal to 1. So this line running down here into this, and you should be reading. Condition is greater than 10, and control device. I don't want to set it to off. I want to set it to control device off. Okay, that's true. That's correct, but that's not how it should work because currently you have 1, so this should be on. Why is it turned off? The device, that one. Iron is greater than 10. And turn that off. Okay, that's not working how I expected, or how I don't see what's wrong there. I don't see. This is generating the signal saying that it's got a 1. This is definitely the right cable, correct? Signal cable to send data. Yep. Ah, hold on. No. Right. The device. That device. Did I get that wrong? Is that the output for the cable? I might have got that wrong. Okay. So you want to be, if it's less than 10. Okay, if it's less than 10, so that's what I got wrong. I had the box the wrong way around. Okay, so okay, there is another step in these here. So that's cool. That means that I don't have to do this. Okay, we can get rid of this here. Let's try and plug them right next to each other. And we don't need this cable either. So we want a 5. We want to plug it in that way. I don't know if they can be plugged in directly to each other. I don't know if that's valid or not. We will find out in just a moment. Pick device. We want to pick that. So long as you've got line of sight, you can see it. Pick that. Ba-dum. There we go. Okay. You have no signal. Okay, so that's not going to work. So you need to have block in between. That's fine. That's fine. That's not a problem. Pick a device. That one. Boom, 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 boom. Okay, and we put a cable in between. Like so. Ba-dum. There you go. You are receiving this here. That's what I got wrong. So it's the orientation of this block isn't the sensor it's reading. That's the signal output. Okay, that's cool. Right. You are reading that inventory, and then you are sending a signal down, and you are reading this here. So you're trying to read on bar, which is good because that means I could have multiple of these, all on the same bar, the same line, going to the same system. If that makes sense. We'll try that in a moment. So you say if there is less than 10, turn on. So the condition is an on condition. Okay, so if there's less than 10 there, turn on. So if we then go 1, 2, 3, 10, boom, you turn off. So there is now not less than 10. There is exactly 10, which is not less than 10. So you would stop. So that's fine. There will be a surplus going in there because obviously this takes 5 seconds to produce 3 bars. So when it hits 10, there might still be ore in here because we're outputting ore from here. But that's good. That's good. That means all we need to do is the stuff that comes down these pipes, we need to filter into storage containers or a warehouse if we want to have multiple outputs. So, but we do want all of this to go into the same smelter, which is why I'm trying to work it on the filters for inputs and outputs and not on the smelter itself, because I don't want individual smelters of different things. So I want this doing all the bars. We want doing all of these here. And then we just have logic saying, hey, if you're reading this or if you're reading that, then here we go. So what if we did like this? So you can read 4 different signals and you will read 1. And then we will go and have a decider here, that. And you're going to read copper, you're going to read gold, you're going to read aluminium. We run a single line between them. Does this work as intended? So this is reading all of these and is generating the signals to do all of these. You are getting a signal here for 10. You're getting a copper signal. You have no device going on there, but don't have any. Okay. Boom. So you're going with copper and control device is on. Oh, because it should be less than. So control device is off. Less than. And then what do we put in here? We put in 5, 3, and 2. In completely the wrong order. Let's filter them. So, oh, gold. Why does gold go first? Why'd you do that? So this is 2. So if we put this up to say 3, it will turn on. So it would. This one would be turning on to do things. So it does. So that's how it works. Okay. So you can have a single line coming along, base chain line, a single sensor which sends signals for each one of these, and each one of these can read individually which one it wants. So that's cool. You will have to have a different decider for each and every filter you want, because obviously you don't want to have a filter here, but you could have multiple readers. It could read iron and copper, and if it's lower than a certain amount, then you turn off whatever you're doing. So, you know, we haven't got enough iron and copper, so we can't make whatever iron and copper makes together. So, yeah. Okay, so that's good. And then all we'd have to have is a belt that goes along and into here to smelt stuff. I might split this 2 ways. So, do we want everything coming into a storage, and then from the storage coming out into individual storage containers, or we could even have the storage itself? Because I need to look at it so it's not going to block up all the belts. That's the thing. When it comes to smelting, this is an example. When it comes to smelting, I'm just going to smelt every piece of ore down to what it is, because we only want to smelt the ore. So it's going to go. These are going to go directly into a smelter, and everything's going to be smelted to iron bars. It's for doing the plate and the copper and all those bits and pieces there, because I don't want to convert all of our iron plates in a constructor. Sorry, all of our iron. I don't want to convert all of our iron bars into iron plates, because we need bars for building things, and we need bars for other things as well in other places. So I don't want to convert all of it. The same with the copper. I don't want to convert it all into plates, because it's also used in other places. So we want to have a certain amount of plates in stock, And then once we've got a certain amount of plates in stock, we'll stop producing plates. But then the plates will be stored somewhere where they'll come out and go on to their next stage. So then, for instance, in the manufacturer, so the plates come out and become wire. So if we have less than however many wire we want, the plates will come out, which means the plates will drop, and then the automatic system will kick in and turn more ingots into plates. That's the plan, at least. That's the plan. Whether the plan's going to work or not, I don't know. I really wish these were configurable on individual sides. That would be so much nicer, but they're not, so we have to deal with it like this. There is a way to do with that, and I think we are actually going to use 2 smelters. Problem is getting it into the next storage. So my idea is going to be, get rid of that there. We come down the pipes and we go into this here. So everything goes into a base warehouse. So every ore we capture goes into a base warehouse. And then out of here, we come out and we go 1 storage container for, well, this one will be iron, gold, will go to 1 smelter. And then copper and aluminium will go to 1, although we're never going to get aluminium in this line. So, yeah. But then we've got another input here, which we could always figure out for getting aluminium in later. I don't know. We'd have to figure out exactly how this works here. So, okay. But that's I have an understanding of logistics now. But I would definitely need to build this a bit better. Why? No. I want to remove. Oh. Uh-oh. We have a broken tile. I repeat, we have a broken tile. That's just a ghost. We'll replace it later. We'll fix that later. So that's my understanding of logistic blocks. That's how they work. That's taken way longer than I thought to figure out. Mainly because of the science. I had to get all the science done, and the science took a lot longer than I wanted to get it done. So, okay. So all the stuff's going to come down, go into smelters, smelt into iron, or smelt into bars, and then the bars are going to be stored in a warehouse. And anything that's not iron, copper, gold, and aluminium will be placed in another storage somewhere, and then we'll figure it out from there. So yeah, at least that's the plan. But it's a plan we're going to have to implement next episode, because time. This episode is already late going out, so time. Fun. So we'll leave this one here. We will come back next time. We shall carry on from there and see what other wonderful fun we can get into. Boop. Both come out that way. I'll put storage here, and we'll build along here and go that way, because that's the way we want to go. So thank you very much for watching. I hope you have enjoyed this one, and I hope to see you again in the next one. Until then, as always, have fun.